In this video, we are going to discuss the relationship between the trigonometric Fourier series and the exponential Fourier series. The relation between the coefficient of trigonometric Fourier series and the exponential Fourier series can be drawn as, let's consider a signal x of t is periodic over the period t naught comma t naught plus capital T. Then the trigonometric Fourier series can be written using this equation: x of t is equals to a naught plus summation where n varies from 1 to infinity, a n cos n omega naught t plus b n sin n omega naught t. So let's suppose this is equation number 1. Exponential Fourier series is represented using this equation: x of t is equals to summation where n varies from minus infinity to infinity, f of n e raised to power j n omega naught t. The exponential Fourier series can also be written as, like if you open the previous equation, then we can write the exponential Fourier series using this equation: x of t is equals to f0 plus f1 e raised to power j omega naught t plus f2 e raised to power j2 omega naught t, plus so on for the positive component, and for the negative component we have f of minus 1 e raised to power minus j omega naught t plus f of minus 2 e raised to power minus j2 omega naught t plus so on. The exponentials can be written as e raised to power j omega naught t. We can write that using the Euler formula, which is equals to cos omega naught t plus j sin omega naught t. So it means that we can replace these exponential using this trigonometric equation, like using this polar form. So f of 1 e raised to power j omega naught t is equals to f of 1 cos omega naught t plus j sin omega naught t. Similarly, f of 2 e raised to power j2 omega naught t is equals to f of 2 cos 2 omega naught t plus j sin 2 omega naught t. The negative exponentials can be written using this Euler formula: e raised to power minus j omega naught t is equals to cos omega naught t minus j sin omega naught t. Similarly, the negative coefficient of approximation with the Euler formula, you can open that f of minus 1 e raised to power minus j omega naught t is equals to f of minus 1 cos omega naught t minus j sin omega naught t. F of minus 2 e raised to power minus j2 omega naught t is equals to f of minus 2 cos 2 omega naught t minus j sin 2 omega naught t. So we can write in a simple form like f of 1 cos omega naught t plus j sin omega naught t plus f of minus 1 cos omega naught t minus j sin omega naught t, where you can see that f of 1 cos omega naught t and f of minus 1 cos omega naught t. So you can take cos omega naught t as a common, and you can write like this: f of 1 plus f of minus 1. Similarly, you can take common j sin omega naught t, and you can write j f of 1 minus f of minus 1 sin omega naught t. Then the simplified form can be written using these equations: x of t is equals to f of 0 plus f of 1 plus f of minus 1 cos omega naught t plus so on, and then plus j f of 1 minus f of minus 1 sin omega naught t plus so on. Then the final equation is written using this equation: x of t is equals to f of 0. This final equation of exponential Fourier series, so you can give it number 2. So then you can compare 1 and 2, and you can say that the coefficient of approximation for the trigonometric Fourier series a naught can be compared with f naught, and a n can be compared with f n plus f minus 1, and b n can be compared with j f n minus f of minus n. Then you can say that if a n is equals to f of n plus f of minus n, and j n is equals to j f of n plus j f of minus 1. So this is equation 1, and b n is equals to j f of n minus f of minus 2. So that's equation number 2. So if you add this equation 1 and 2, then you can say that f of n is equals to 1 over 2j j a n plus b n. And if you subtract equation 1 and 2, then you can say f of minus 1 is equals to 1 over 2j j a n minus b n. So it means that you are end up with the relationship between the coefficient of approximation of the trigonometric Fourier series and the exponential Fourier series. So you can use these relationship in one series to another series. So these are very important relationship in order to calculate a relationship between these two series, like the trigonometric Fourier series and the exponential Fourier series.